Alright, so here we have section 6.1. We're going to start chapter 6, which is going to be about similar figures. And what we're going to do today is we're going to use similar polygons. So the first thing we're going to start off with is defining what it means to be a similar polygon. There are two parts to our definition. The first one is going to say that all of the corresponding angles are congruent. So that's going to be very similar to our congruent triangles. In congruent figures, we're going to still look at our corresponding angles and corresponding parts, but our angles are going to be congruent. And then the second part is going to be that all of our corresponding side lengths are going to be proportional. They're not going to be the same, but they are going to be proportional. So our shape is going to stay the same, but our size is going to change. So for example, here we have figure ABCD, so we have a quadrilateral here, so we have quadrilateral ABCD and a quadrilateral EFGH. Here all of my angles are going to be the same, so I have angle A is congruent to angle E, angle B is congruent to angle F, angle C is congruent to angle G, and angle D is congruent to angle H. But what is special is that all of these sides are going to be proportional, so they're going to have the same ratio to each other. And if you can kind of see, they look exactly the same, but one's smaller than the other. So here's our first example, and we're going to look at the fact that these triangles are already similar, and we just want to find the ratios of proportionality of all of our sides. So we're going to look and see how the sides are different from congruent triangles. So go ahead and copy this down, and whenever you're ready to start, go ahead and press play. Alright, so the first thing we're going to do is we're just going to take two corresponding sides of our triangles. So I know that RS is going to be corresponding to XY. So what I do is I just put one over the other, and whichever one I put on top, I'm going to keep on top for all of my ratios. So here I know that RS is corresponding to XY. So when I write my ratio and I plug them in, I know that we're going to have 20 over 12. And we have a common factor of 4 in both of those. So we can take a 4 out, and that's going to simplify to 5 over 3. What I want you to do is try and see if you can figure out the other two proportions, and just press play whenever you're ready. Alright, so hopefully it wasn't too hard. All you had to do was go in, and I know that RT is corresponding to XZ. So then we're just going to go in and put 25 over 15, which simplifies to 5 over 3. And then we're going to do the same thing for our last two sides, which are going to be TS and ZY. And then you just go and plug them in. So we get 30 over 18, which simplifies to 5 over 3. Now a special thing that happens is when we have, what it means for all of our sides to be proportional is that they all have the same common ratio. So here all my common ratios are 5/3, so I know that these figures are proportional to each other. This is going to be called our scale factor. We'll get to that in just a second. I have another example for you in just a second. Okay, so in this example we're going to use similar figures and proportions to find x. Okay, so basically what we're going to do is we're going to set up an equation based off of our proportional sides. So just pick two sides, one of them being x. Okay, what I'm going to do is I'm going to pick 9 and 12. So I have DE and MN. And then I'm going to look at EF and NP. So I know DE is 9 and MN is 12. So I'm going to put 9 over 12. Since I started with DE, I need to start with EF on top on the other side of my equation. So now I have EF over NP, so I'm left with x over 20. Alright, all we're going to do after that is we're going to solve it. Okay, so see if you can remember this. If you can't, go ahead and press play. If not, see if you get the same answer as me. Alright, so all we do in order to solve it is cross multiply. So take 20 and multiply it by 9, and take 12 and multiply it by x, and stick an equal sign in between it. So then you get 9 times 20 equals 12 times x. Simplify. You get 180 equals 12x. And then in order to get x by itself, we have to divide both sides by 12. So then we're left with x equals 15. So like I mentioned earlier, we also have to define scale factor. Scale factor is merely going to be the ratio between the two lengths of two corresponding sides when we have similar polygons. So like in example 1, our common ratio was 5/3. So all we're going to do is we're going to say the scale factor from the bigger triangle to the smaller one had a scale factor of 5/3. Alright, so this is going to be the only kind of tricky thing about scale factors. Is just you got to kind of visualize what it means to be a scale factor. So, for example, we have two similar polygons here. We have a triangle ABC, and it's similar to triangle EFG. So I don't have to go in and find a common ratio. I already know that they have one, or I don't have to go and find one for all of them, because I know that if I find them for one of my pairs, then it's going to be the same common ratio for all of them. So what I want you to do is pick a side and find its ratio. I'm going to look at side AB to EF because I'm going to go from triangle ABC to triangle EFG. So what I want to do is I want to put my first triangle on top and then the second triangle I'm going to on the bottom. So then when I go and plug it in, I'm going to have 10/5, which is going to simplify to 2. So when I'm going from triangle ABC to triangle EFG, I'm going to have a scale factor of 2. Alright, so now we're going to look at the scale factor from going from triangle EFG to triangle ABC. Alright, so now since we're starting with triangle EFG, pick a side that's on our triangle EFG. I'm going to do segment or side FG, and so the corresponding part to FG is going to be BC in triangle ABC. So when I plug in my sides, I get 4/8, so then that simplifies to 1/2. So when I'm going from triangle EFG to triangle ABC, I have a scale factor of 1/2. So this is going to be today's lesson. If you have any questions, go ahead and ask them now. If not, go ahead and start on the problems assigned to you.